External is this pinna or auricle, your ear. External auditory canal, tympanic membrane. That's your external ear. Your middle ear, which they're all here. Here's the malleus, which is in contact with the tympanic membrane. The incus, and then the stapes attaches to right there. It's like a little stirrup. So the malleus, incus, and stapes are the bones of the middle ear. Another thing is this auditory tube or eustachian tube right here, which goes to the back of your throat to equalize pressure in the middle ear. Okay, to get the pressure change, because there's going to be pressure pushing against the tympanic membrane, so it's going to be going in. You equalize it by putting the same pressure on this side, and it straightens back out. And this part is the inner ear. This was the inner ear. Did you want to go over that or what?
Yeah.
Okay, I got to get inner ear. The inner ear, there are several parts. The whole outside is covered with bone, so that's the osseous labyrinth. There's an almost identical copy inside the membranous labyrinth. See, it follows all the tubes and stuff. It's an almost identical copy inside. That's the membranous labyrinth. It's gray on this model. In between the osseous and membranous is a fluid called it's pink on here, called the perilymph. And inside the membranous you can't see, it's called the endolymph. Okay. There are 3 of these canals: anterior semicircular canal, posterior semicircular canal, lateral semicircular canal. In the base of each of these canals is a swollen vessel called an ampulla. And each of the ampullas inside of their membranous labyrinth contains a cristae, which is I have that on the board. It's a cell, a receptor cell, that's going to monitor fluids moving through the membranous labyrinth. So it monitors a type of equilibrium called dynamic equilibrium, movement through space. When the fluid goes through there, it bends them. In whichever direction it bends, that's going to be interpreted as movement in a particular direction. The vestibule, this part in the middle, has 2 parts, the utricle and the saccule. They both contain another type of receptor called the macula. And the macula, which is on the board too, is a layer of hair cells with a gelatinous membrane on top and then crystals on top called otoliths. And when you are not straight up and down and you lean forward, the crystals pull forward and it bends the hairs forward, and that lets you know that you're not standing up straight. You straighten yourself back up and they're straight. And you lean to the side, it shifts to the side, and impulses are generated that say you're not straight. You lean to the side and straighten back up. So these are for static equilibrium, your orientation relative to gravity. And you move down into the cochlea. Okay. Now, this was the stapes that's your middle ear bone that's going to attach here to this oval window. And this has got another tympanic membrane covering the round window. When you open this up, you're going to see different lengths or different parts of this tube from the very first, a little further down, further down, further down, toward the end. It's the same. They're the same chambers all the way down, but it's a tube that's been coiled up, so it's the same thing all the way down. And we've got the model, which you got to get. It's going to show these 3 chambers. Okay. The one that's pink on here is the scala vestibuli. The one that's green is the scala tympani, And the one in this blue is the scala media or the cochlear duct. Now you need to get the bigger model, like that one right there, to see inside. That big guy. Stapes is attached to this chamber here called the scala vestibuli. That's where the oval window is. So this is the scala vestibuli. The vestibuli goes all the way down that spiral to the helicotrema, and then the lower chamber is this one, scala tympani. That's the one that has the round window, which has the second tympanic membrane on it for pressure relief. Both of these have perilymph. One in the middle has endolymph. This is your cochlear duct or scala media. This one right here is full of endolymph. The membranes of this membranous labyrinth here, the scala vestibuli, named after the vestibular duct here, scala vestibuli, vestibular membrane. This is the basilar membrane. The hair cells sit on top of the basilar membrane. So the hair cells have their little hairs that are stuck into this tectorial membrane here. The hairs go all the way down to the helicotrema, and they're embedded in the tectorial membrane all the way down to the helicotrema, and this is all the way down too. So that goes, this duct goes all the way down to the helicotrema. When shock waves hit in here, pressure wave is transferred across the media into the tympani, and the pressure is relieved. It transfers across, depending on what the frequency is, it causes this to bounce according to the frequency of the wavelength that you're hearing. High-pitched sounds are closest to the stapes, low-pitched sounds are further down. Okay. These hairs, when they generate an impulse, this has kind of come loose here, but these are going to become the cochlear branch of the vestibulocochlear nerve. And you can see that on the models. Like this one's missing one of them, but this is the cochlear branch coming out of the cochlea for hearing. This is missing everything, but there's another branch that's like over here that goes to the vestibule. It's going to pick up impulses from the cristae and the macula, and it's called the vestibular branch. So on this model, it's just going to be these two coming out here. Vestibular branch of the vestibulocochlear nerve. Okay, so that's what cranial nerve number 8 is called, the vestibulocochlear nerve.